Hello, this is Reid presenting my top 20 project on lime. The history of lime. Lime, also called calcium oxide, is a white crystalline solid. It can be made by heating limestone, coral, seashells, or chalk, which are composed of calcium carbonate. Lime is one of the oldest chemicals made in the history of the world, and there is no definite inventor of the chemical. Most ancient civilizations have a word for it, but in Latin the word is calx. Lime is very abundant in Earth's crust and is still mass-produced and used in many things today. The properties of lime. Lime has many physical and chemical properties. For example, physically it is a white powder, odorless, the melting point is 2,572 degrees Celsius, boiling point is 2,850 degrees Celsius, and it is soluble in water, acids, but not methanol. Some of the chemical properties of lime include its pH level 12.5, it is non-flammable, reacts with carbon dioxide to form calcium carbonate, makes heat energy when reacting with a hydrate, and when it is heated to 2,400 degrees Celsius, it emits a bright light that is often called the limelight. This is a full-page diagram of calcium oxide. When the calcium bonds with chlorine, two chlorine atoms are needed to take up the two electrons from the calcium's outer shell. Uses today. Lime is one of the most used chemicals today and is very useful. Before electricity, it was often used as lighting, as shown in this image, hence the term limelight. Calcium oxide is a key ingredient to making cement, which is obviously used across the world, making it very useful. In paper, calcium oxide is used to regenerate sodium hydroxide from sodium carbonate at pulp mills. In plaster, there's a limestone-based version that is mostly used for flooring, and used to be much more popular but not used as much anymore. Lastly, in petroleum, calcium oxide is used in a mix, put in storage tanks, to detect water. Although calcium oxide is very useful, it also has hazards. Calcium oxide can be harmful to the body when eye, skin, or your respiratory system comes in contact with it. It can become problems through inhaling, ingesting, or even just getting it on your skin. It causes irritation in the eye, skin, and respiratory tract. It can cause an ulcer, pneumonitis, and dermatitis. The environmental effects are very small if used properly. When mixed with water, it should react quickly without any problems or hazards into calcium hydroxide. The high pH level in nature is reduced to 7.8 or 8.5. However, the normal precautions taken with chemicals must be taken, such as glasses, aprons, and not breathing it in. The main hazard of calcium oxide is to the human body because it can be corrosive to your respiratory system and give permanent damage if you take in too much. This is the cover of the MSDS page for calcium oxide. In it you can find product information, hazardous ingredients, physical data, and first aid measures. As you can see, calcium oxide can only be bought in bulk but for a relatively low price. Depending on what kind you want, you can get it anywhere from $70 per ton to $300. This is my 3D model of calcium oxide. This is my model for calcium oxide. The white ball represents calcium, and the red ball represents oxygen. Because calcium has a negative 2 charge and oxygen has a positive 2 charge, you only have one of each molecule. There's also only a single bond, and that's why the molecule is the way that it is. For the bibliography, each URL was put in its respective picture, along with the information that started with each title. Thank you for listening. This was Reid presenting my top 20 project on lime.